All right, so we're on problem 13, part A of the final exam practice, and we want to find the radius and interval of convergence for this power series. So this power series starts at n equals 1 and goes to infinity, and the terms look like x divided by n to the power n. So we're going to be calling a sub n, this is the nth term of our power series, this is x divided by n to the power n. Okay. And we would like to determine the radius of convergence. So to find the radius of convergence, we can either use the ratio test or we can use the root test. And since we have terms that look like x divided by n, so some expression to the power n, we'll use the root test because it'll actually be very simple to use the root test here. So let's use root test. And so with the root test, we're looking at the nth root of the absolute value of the nth term, and we want to ultimately evaluate the limit as n goes to infinity. And so in this case, this is equal to the nth root of absolute value of x divided by n to the power n. And so nth root and nth power, this is why we wanted to use the root test from the beginning. This is just equal to absolute value of x over n, and taking the limit as n goes to infinity for any fixed x, the numerator stays constant at absolute value of x, and the denominator goes off to infinity, and so this goes to 0. So either way, 0 is always less than 1, and with the root test, if the limit of these nth roots of the absolute value of the nth term of our series goes to a number less than 1, then our series is absolutely convergent for that value of x that we used. But in fact, it doesn't matter which value of x we use here. X can be any real number, and this denominator of n tending to infinity will always make this limit equal to 0. So this is going to be defined for any value of x, and so our radius of convergence here is equal to positive infinity. All right, so the interval of convergence is defined by the fact that the radius of convergence is positive infinity, and so our interval is going to look like minus infinity to plus infinity, and there's just no other way for it to be. All right, and so we're done with part A.